Hello viewers, the current video is part 3 of the chapter Solid Figures. In this video, I'll speak about solid sphere, hollow sphere, solid hemisphere and hollow hemisphere. I'll discuss formula of volume and total surface area of the above mentioned solids, and then I'll take some questions based on these solids. Let's start the topic. A sphere or solid sphere. Definition says a sphere is a solid obtained on revolving a circle about a diameter of it. The meaning is take a circular lamina and draw any diameter of that circular lamina and treat that diameter as axis, and about that axis you rotate the circular lamina. You'll observe that a space is covered by that rotating circular lamina, and that gives the shape of a solid sphere, and radius of the solid sphere obtained by revolving circle is the radius of the circle itself, and radius of the revolving circular lamina is equal to the radius of the sphere formed by revolving lamina. Volume of the solid sphere is 4 by 3 pi r cube, where r is the radius of the solid sphere, and surface area of solid sphere is 4 pi r square, where r is the radius of the solid sphere. Let's come to spherical shell. The definition says the spherical shell is a solid enclosed between two concentric spheres. So it is a hollow sphere with uniform thickness, where thickness is the difference of the two radius. Let capital R and small r are the outer and inner radius of a spherical shell, where capital R is greater than small r. Hence, thickness of the spherical shell is capital R minus small r. External volume. External volume of the spherical shell is 4 by 3 pi capital R cube. Internal volume of the spherical shell is 4 by 3 pi small r cube. Next, volume of the material used in manufacturing spherical shell is external volume minus internal volume. The expression is 4 by 3 pi capital R cube minus 4 by 3 pi small r cube, where 4 by 3 pi capital R cube is external volume and 4 by 3 pi small r cube is internal volume. The simplified expression for volume of the material is 4 by 3 pi multiplied by capital R cube minus small r cube. This capital R cube minus small r cube can further be simplified using algebraic formula of a cube minus b cube, that is equal to a minus b multiplied by a square plus ab plus b square. Next terms are hemisphere and hemispherical shell. The definition of hemisphere says when a solid sphere is cut through its center into two equal or identical pieces, each piece is called a hemisphere. Hence, volume of hemisphere is half the volume of the sphere. That is equal to 2 by 3 pi r cube, where r is the radius of the hemisphere. Next is surface area. As we know, in case of a sphere, the total surface area is circular. But when it is cut to two equal halves, each half becomes a hemisphere and a new circular plane area is created. Therefore, surface area of a hemisphere is half the circular surface area of the sphere plus the new created circular area, and that is called base area. Here 2 pi r square is the curved surface area of the hemisphere and pi r square is the area of new created plane circle. Altogether, total surface area of hemisphere is 3 pi r square. Here the radius of the circular surface area and the radius of the plane circular base created are same or are equal. Hemispherical shell. The definition is when a spherical shell is cut through its center into two equal halves or into two identical pieces, each piece is called a hemispherical shell. Before I start discussing formula, let's assume that capital R is the external radius and small r is the internal radius of hemispherical shell. Here, external volume of hemispherical shell is 2 by 3 pi capital R cube and internal volume of hemispherical shell is 2 by 3 pi small r cube. Hence, volume of the material used in hemispherical shell is external volume minus internal volume. Therefore, the expression for volume of material in the hemispherical shell is 2 by 3 pi capital R cube minus 2 by 3 pi small r cube, and the same expression in simplified form is 2 by 3 pi multiplied by capital R cube minus small r cube, where capital R cube minus small r cube can be simplified further using algebraic formula a cube minus b cube equal to a minus b multiplied by a square plus ab plus b square. The surface area of a spherical shell is a combination of external curved surface area, internal curved surface area, and the surface area of an annular created. In the expression for surface area, 2 pi capital R square is external curved surface area, 2 pi small r square is internal curved surface area, and pi capital R square minus pi small r square is area of the annular. In simplified form, 2 pi multiplied by sum of the square of the two radius is the sum of external curved surface area and internal curved surface area. Hence, total curved surface area is 2 pi multiplied by capital R square plus small r square, and area of the annular is pi multiplied by capital R square minus small r square. I have discussed formula for volume and surface area of sphere, hemisphere, spherical shell and hemispherical shell. Now let's take some questions based on solid sphere, solid hemisphere, spherical shell and hemispherical shell. Question number 9. The question says, how many spherical balls, each of radius 1 centimeter, can be made by melting a bigger metallic ball of diameter 8 centimeter? The meaning of the question is, there is a big metallic solid sphere of diameter 8 centimeter. This sphere is melted and recast into small spheres of radius 1 centimeter. The question is, how many small spherical balls will be generated? We know that in the process of melting one metallic object and creating another object, volume remains fixed. Hence, the volume of all the small balls generated is equal to the volume of the bigger spherical metallic ball. Therefore, number of small balls generated is equal to volume of the bigger spherical metallic ball divided by volume of the small spherical ball. In the given expression, the numerator 4 by 3 pi capital R cube is the volume of the bigger metallic ball, and the denominator 4 by 3 pi small r cube is the volume of a small spherical ball to be generated. In this expression, 4 by 3 and pi gets cancelled and the value of capital R is 4 centimeter. Value of small r is 1 centimeter. Hence, the result obtained of this expression is capital R cube by small r cube, and that is 4 cube by 1 cube, and the answer is 64. Hence, the number of small balls generated is 64. Let's take another question. Question number 10. The question is, the volume of one sphere is 27 times that of another sphere. Find the ratio of their radii and surface area. Let's assume two spheres, sphere A and sphere B. From the ratio of their volumes, it's clear that sphere A is bigger than sphere B. According to question, volume of sphere A divided by volume of sphere B is equal to 27 by 1. In this relation, here 4 by 3 pi capital R cube is volume of sphere A and 4 by 3 pi small r cube is volume of the sphere B, and the ratio is 27 by 1. The simplified relation obtained is capital R by small r whole cube is equal to 3 by 1 whole cube, and it results in capital R by small r is equal to 3 by 1. Hence, the ratio of their radii is 3:1. Next is the ratio of their surface area. So, surface area of sphere A by surface area of sphere B is equal to 4 pi capital R square divided by 4 pi small r square. And the simplified expression obtained is capital R by small r whole square, that is equal to 3 by 1 whole square, because the value of capital R by small r is 3 by 1. Finally, the result obtained is 9 by 1. Hence, ratio of their surface area is 9:1. Here is the result finally recorded. Number 1, ratio of their radii is 3:1 and ratio of their surface area is 9:1. The next question is question number 11. Metallic spheres of radii 6 cm, 8 cm and 10 cm are melted and recast into a single solid sphere. Find its surface area. The easier way to solve this question with negligible calculation is to equate the volume of the sphere formed with the sum of the volume of the three spheres mentioned in the question. In this given relation or equation, 4 by 3 pi r cube is the volume of the bigger sphere formed. That is equal to the sum of the volume of all the three spheres, that is 4 by 3 pi r1 cube plus 4 by 3 pi r2 cube plus 4 by 3 pi r3 cube. The equation in simplified form is r cube is equal to r1 cube plus r2 cube plus r3 cube, where r1 is 6 cm, r2 is 8 cm and r3 is 10 cm. The value obtained 1728 is the sum of 6 cube, 8 cube and 10 cube, and this value is the cube of 12, that represents r cube. Hence, the radius of the bigger sphere formed is 12 cm. Now, surface area of the sphere formed is 4 pi r square, where pi is 3.1 suggested in the question and radius is 12 cm. Hence, the expression is 4 multiplied by 3.1 multiplied by 12 square. Finally, the surface area of the sphere generated is 1785.6 centimeter square. Let's take another question. Question number 12. A hollow sphere of internal and external radii 6 cm and 8 cm respectively is melted and recast into small cones of radius 2 cm and height 8 cm. Find the number of solid cones formed. Since the sum of the volume of all the cones generated is equal to the volume of the hollow sphere, hence the number of cones formed is volume of the sphere divided by volume of a cone. In this given expression, the numerator is the volume of the hollow sphere to be melted and the denominator is the volume of one of the cones formed. The simplified expression is 4 multiplied by 512 minus 216 whole divided by 4 multiplied by 8. The further simplified expression is 4 multiplied by 296 whole divided by 4 multiplied by 8. And the final result is 37. Hence, the number of identical cones formed is 37. In this video, I discussed volume and surface area of solid sphere, solid hemisphere, hollow sphere or a spherical shell, and hollow hemisphere or hemispherical shell. And then I took some questions to discuss based on the above mentioned solids. I suggest you to take some questions from your book which are simple and related to these geometrical figures discussed in these three videos. Thank you.